get the answer right. What's the bonus?
Whoa, whoa, whoa. Did you write it down?
We did. We did.
You did right.
Yes.
Two. Page 2. The white. Alrighty, guys. The whole purpose of the game was for you guys to be more conscious and observative of what you think, and then taking what you think and writing it on paper. Okay, now that seems like an easy process, but some of these you guys had trouble. It's like you knew it was right, maybe, but it was hard for you to reason why. So that part of your brain that does the reasoning, that's what we're trying to harness right now. Okay, last class we talked about something called narrative proofs, where you just write like paragraph. Today there's 2 formal proofs. The 2 formal proofs are what's called 2-column and something called webbing. In 2 columns, it's called 2 columns because you have 2 columns. Sorry, it's not very complex here. How goes on the left. How goes on the left and the why goes on the right. I told you on proofs what is not important, unlike other math classes. How is on the left, what is on the right. In the videos, the more traditional titles for these are statements and reasons. I like to read it like a sentence. I know that because. That's how I read those. That's called a 2-column. On the right, webbing. The hows go in the boxes in webbing. And the reasons why go between the boxes. In webbing, I see it like this. You go from one step to the other. I call it the Mother May I. When you play Mother May I as a kid, you go one step, and before you take the other, you have to ask, Mother May I. So the why is the reason to go from one step to the other. That's your why. I'll call it the Mother May I. Now, in your bright yellows, that's going to be called the DPTP. I want you to find these headings way at the top. Algebraic properties. How to show angles congruent and other angles theorem. I'd like you to look way at the top and flip through until you can see those 3 titles. Just flip through. That, put a little check mark by them. Algebraic properties is the very first page, guys. Okay, turn to page, leave your DPTPs open. That's those yellow things. Now turn to page 3 in the white packet. Turn to page 3. Page 3, please. Page 3. I'm going to walk you through 1 2-column proof. And then you're going to do 1 on your own. Okay, we're going to follow gift just like before. It says given. So it says read the given, carefully mark on the diagram. 1 is equal to 3. So I sweep 1, I sweep 3. Hatch, hatch. Do that with me. And then cross it out. What else am I given? I'm given 2 is equal to 4. So I know 2 is equal to 4. Cross it out. What am I trying to find? EYG trace and sweep. EYG HG is congruent to HZK. That's what I'm trying to prove, so I'm going to pull a question mark by it. That's not part of my given, it's what I'm trying to prove. Okay, so we've done the given and the proof. There's no vertical angles, there's no linear pairs, so there's no freebies. But let's see what's implied here. Don't overlook something that's really simple like this. Angle 1 plus angle 2, so just squiggle it and put a little plus sign. Those two angles together equal the big angle. Be very careful not to overlook the obvious. These two angles together, so I'm going to squiggle, put a little plus sign, put an arrow. They equal the big one. Okay, that's implied. Now in your teams, I want you to talk it through. If you know these two statements are equal, how do you know those big angles are equal? Ready? Talk.
I'm sorry, I need to use it.
Okay, guys, I actually want you to talk this through. Good? That fast? Did you guys talk it through? All right, so let's take a look at how to do this. Okay, using a proof. Now, I've been really nice in the fact that I actually gave you this half done. Eventually, you'll do these completely blank, but you're just starting. So look what I have here. I have the how already done for you. You only need to come up with the why. So we find angle 1 and 3 are congruent. Where do we find that information? Given. Okay, so some of this is not difficult. It's given. Okay? 2 is equal to 4, it's also given. Now let's look what we have here. We have angle 1 plus angle 2 equals the big angle. Now that's not given. What we have, it is implied, but you can't just say implied, it has a name. What we have here is little angle plus little angle equals big angle. That's called angle addition property. I want you to use angle addition. I want you to say, because that's what's going to match Alex. Angle addition property. All angle addition is little angles add up to big angles. So Brennan, on my test, if you want to do this, I'll take it. But on Alex, you just need to know that Alex is going to use this. Okay? Now, as a team, I want you to briefly discuss what is the only thing different. Ask yourself, what happened between lines 3 and line 4? Talk about it. Go.
Nothing.
Figure it out. What happened between 3 and 4? Something changed. Talk about it. Go. I want you to talk about it. What happened between line 3 and line 4? What happened between line 3 and line 4?
Yeah.
They add together to make a PK. It's proving that they are therefore equal.
All right. I'll give a volunteer for this one. Who wants to raise your hand and tell me what happened between 3 and 4? Ben.
They changed the angles.
What angle swapped out with what angle?
Changed angle 1 and 2 to 3 and 4.
Okay, so 1 got swapped with what? 3, and that's because of line 1. And then here, 2 swapped with 4. Okay, so that's called substitution. We swapped out one and put in the other. So you write substitute.
That's what lines they're talking about.
Aha, yes.
They're talking about like a line.
For example, you would know which line it means, line number 1, line 2, line 3. Okay, so we substituted angle 3 for angle 1 and angle 4 for angle 2. I'm going to spell out very specifically what was swapped with what. This one, 3 and 4 add up to the big one. That's just little angle plus little angle equals big angle. Now, I'd like you to box 3 and 4, please. Here, box 3 and 4. And box this 3 and 4. Since 3 or 4 are equal for both, that means these are now equal. So I can say EYG is equal to that, Y substitution. I substituted 3 and 4 for the bigger angles. Yes, sir?
Did you also say reflexive?
No. Reflexive is when something's equal to itself. Something's equal to itself. All right. Using that as a model, I want you to walk through page 4, and then I want you to check page 4. Do page 4, check page 4. Go. Lights on.
Oh.
Blink, blink.
We have a class with no lights.
Huh?
We have no lights.
It's our,
No.
for people, some people. Okay, guys, make sure you mark on the diagram first. Guys, don't ignore the diagram, please. Do not ignore the diagram. Okay, now box what 1 and 2 equals, which is EZG. Now box, where else do you see EZG? So you should see, basically what we've done is we've taken EZG and we swapped it out and we put in 1 and 2. Why? Because up here we say they're equal. Okay, let's try another one. I'd like you to circle the 3 and 4 here. Circle 3 and 4. See, this is what I mean by think. You have to think with your hands. You got to learn to connect stuff. Box and Charlotte. Now circle 3 and 4 here. Now circle, what is 3 and 4 equal? Go check. Now circle here what it equals, HXK, so you can see we take 3 and 4 and we swap it out. So line 4 is substitution. We swapped out the larger angles for the expressions. Okay? That's what I mean by brain is in your hand. You have to learn to physically mark stuff up. Okay. Page 5 is called a web. A web. Taylor? Okay, a web shows how things fit together. A web shows how things fit together. A 2-column does not do this. Okay? So first you follow the same process of gift, and we're going to do that right now at the top. Okay, we're going to follow the same process as gift way up here. This little diagram means perpendicular. So we want to trace AB is perpendicular to CB. That means there's a right angle there, so sweep and put a 90 degrees. We're on page 5. Page 5. They're perpendicular, so I cross it out. Next, DB is perpendicular to EB, so we trace DB, we trace EB, and we sweep 90 degrees as well. Okay, angle DBC is 25. Cross it out. We're trying to explain why. How do we know EBA is 25? No, at this point, stop. Talk about it in your groups, 30 seconds each. How do you get from the left to the right? Go, in your groups.
ABC was 90. Thank you.
Alrighty, guys, look up here. Okay, hopefully you've had a chance to talk it through, so now we're going to do this together. Okay, so step number 1, we are told that AB and CB are perpendicular. That gave us this at 90. How do we know that? It's given. Now, because of that, we know this angle. That DBC and ABD, they have to be complementary. Why? They add up to 90. So, why do I know that? If perpendicular, then 90 degrees. 90 degrees gave us that word, complementary. So this is how, this is the Y. Then we had the second given, DB and EB are perpendicular. How do we know it's given? So now I know that EAB is also complementary to ABD. Okay. If you have a highlighter, highlight in these two boxes. There's a couple things that are exactly the same. Highlight it. Go. Yes, sir.
Would that be DEA?
Yes, where we're going, there's a typo there. Okay, so we notice that ABD is the same for both. Since that's the same for both, we can connect these two. So we have DBC here. This should read EAB there. And why are they congruent? Because if complementary to the same angle, comp to same, then congruent. If comp to same, then congruent. Complementary to the same angle, then congruent. Okay, yes. Yes.
Oh, I was saying that EAB would be that.
EB. Okay, is it? Oh, you are correct. EBA. EBA. I don't want to hit the erase button because then it messes everything up. Okay, this is EBA. Okay, so now we have angle here. What's given is DBC. What?
Oh,
Okay.
it's okay.
Because it's given. And now because we have these exactly the same, we can combine these two, which is EBA and 25, to what we're trying to prove.
There's missing a B.
You know? I know. It doesn't like me. It should end with EBA equals 25, guys. EBA is 25. Okay. I want you guys take a shot at page 6, please. Take a shot at page 6. Go.